In the previous module, you have learned how to set up a tool. Now you are ready to learn how to create a simple program. In this module, you will learn the characteristics of the motion types J, L, P, and C, how to determine which motion type to use, how to determine the motion types in the software. In its simplest form, a robot program consists of a number of waypoints and motion between these waypoints. The waypoints tell the robot where it has to position the TCP, and the motion determines how the robot moves the TCP from one waypoint to another. For example, this is a move L, which is a linear motion that moves the TCP in a straight path from one waypoint to another. This motion type is typically used when the robot has to pick up or place an item and the path of the TCP is important. For example, to put an item straight down or when lifting it and clearing it from a surface, move L is also suited for motion in confined space to avoid collision. When using a move J, also known as a joint move, the robot moves the TCP from one waypoint to another in a non-linear path. Since the TCP doesn't have to follow a specific path, the robot is able to move faster than in other motion types. Use this motion type when the path of the TCP is not important and when moving in free space. Move P, or move process, is somewhat similar to move L, since the motion of the TCP is also linear. The distinct feature of move P is that the TCP moves at a constant speed, which is particularly useful in robot programs for welding or dispensing glue to ensure even distribution. When maintaining a constant TCP speed, the TCP is not able to make sudden turns of direction at sharp angles, as this would require the TCP to slow down. To maintain the TCP speed, the robot has to make a softer turn, which is called a blend radius. Without any sharp angles, the robot is now able to move the TCP at a constant speed. When move P is used, it is also possible to make a circle move, which consists of two waypoints. A circle move must always be preceded by a waypoint from where it will start the circle move. The first waypoint of the move C specifies a via point on the circular arc, and the second waypoint is the end point of the movement. Let's do some exercises to train you in choosing the most suitable motion type. In this example, the robot has to move the workpiece from the roller belt into the cardboard box. To do so, 6 waypoints are needed. Let's find out which motion types you should use getting to each waypoint. Which motion type should you use to move the robot from its current position to waypoint 1? Correct. Since the robot is moving in free space and the path of the TCP is not important here, move J is the best and fastest option. Which motion type should you use to move the robot from its current position to waypoint 2? Correct. The robot needs to move the TCP downwards in a linear motion to be able to pick up the workpiece. Move L is the best choice here. Which motion type should you use to move the robot from its current position to waypoint 3? Correct. The robot needs to lift the workpiece directly upwards to clear it from the conveyor belt. Move L is the best choice here. Which motion type should you use to move the robot from its current position to waypoint 4? Correct. The robot is moving in free space and the path of the TCP is not important. Move J is the best and fastest option. Which motion type should you use to move the robot from its current position to waypoint 5? Correct. The robot needs to move the TCP downwards in a linear motion to be able to place the workpiece. Move L is the best choice here. Which motion type should you use to move the robot from its current position to waypoint 6? Correct. The robot needs to move directly upwards to stay clear of the workpiece. All the motion types needed for this program have now been determined. The next step is to create the program in Polyscope. Click the Teach pendant to get started. To the left of the Structure tab, you'll see the Program tree, which is where you insert commands to build your robot program. Click the Move button to insert the first command. A Move J and a waypoint are now inserted in the Program tree. Next step is to input the physical location of the waypoint. Then click the Command tab and set this waypoint. Now drag the TCP to the first waypoint and click the Teach pendant icon afterwards. Click OK to save this waypoint. You have set up the first waypoint. To add the next waypoint, click the Structure tab and click Move J in the Program tree. Then click the Move button to insert the next waypoint. You have to change the Move J to a Move L, and click the drop-down menu in the upper right corner. Select Move L. Next, set the location of the waypoint by clicking on the waypoint in the Program tree. And then drag the robot to the next waypoint and click the Teach pendant icon afterwards. Click OK to save this waypoint. The third waypoint is also a Move L. To add another waypoint of the same type, click Add Waypoint after and set this waypoint. Next, drag the robot to the third waypoint and click the Teach pendant icon afterwards. Click OK to save this waypoint. Now you have set up waypoint 3. The next motion you need is a Move J. Click the Structure tab and click on Move L in the Program tree. Now click the Move button to insert in the Program tree, click the new waypoint, and click the Command tab. Next, drag the robot to the next waypoint and click the Teach pendant icon afterwards to save this waypoint. Now you have set up waypoint 4. The next move is a Move L. To insert this, click on the last Move J in the Program tree, and then click the Structure tab. Now click to change the Move J to the Move L. Next, click the drop-down menu and select Move L. Then click the waypoint and set this waypoint. Drag the robot to the next waypoint and click the Teach pendant icon afterwards. Click OK to save this waypoint. Now you have set up waypoint 5. There's just one waypoint remaining, which is also a Move L. To add another waypoint of the same type, click Add Waypoint after. Then click Set this waypoint. Now drag the robot to the last waypoint and click the Teach pendant icon. Click OK to save this waypoint. You have now created all the waypoints and motions needed to run this program. Let's do another exercise. In this exercise, the robot has to dispense an even amount of glue to the workpiece. 9 waypoints are needed for this program. Which type of motion is best suited to get from the current position to waypoint 1? Correct. The robot is moving in free space, and the path of the TCP is not important. Move J is the better and faster choice. Which motion type is best suited to get from the current position to waypoint 2? Correct. The robot has to move the TCP down to the workpiece in a linear motion, so move L is the best choice. From waypoint 2 to 3, the robot has to speed up to reach the speed at which the glue will begin dispensing, beginning from waypoint 3. Which motion type is best suited to get from the current position to waypoint 3? Correct. Using the move P ensures the TCP does not slow down when reaching waypoint 3 and moving on to waypoint 4. This means the TCP moves at a constant speed, which ensures even distribution of the glue. From this waypoint. Correct. Using move P ensures the TCP does not slow down when reaching waypoint 4 and moving on to waypoint 5. Which motion type is best suited to get from the current position to waypoint 5 while dispensing the glue? Correct. Here a circle move is needed, which can only be created by using a move P. The circle move consists of 2 waypoints, which means that waypoint 5 is the first waypoint, or the via point in the circle move, and waypoint 6 is the second waypoint, or the end point. Which motion type is best suited to get correct? Using move P ensures the TCP does not slow down between the waypoints. From this point, the robot will stop dispensing glue. Which motion type is best suited to get from the current position to waypoint 8? Correct. The TCP still has to maintain the same speed for a short while after it has stopped dispensing glue to avoid uneven distribution. Which motion type is best suited to get from the current position to waypoint 9? Correct. The robot has to make a linear motion to clear the TCP from the workpiece. Move L is the best choice. Now all the motion types for this program have been determined. The next step is to create the program in Polyscope. Click the Teach Pendant icon to begin. Click Program Robot and Empty Program. Then click the Structure tab. To insert a motion and a waypoint, click the Move button. Next, afterwards, click the Command tab and Set. Now drag the TCP to waypoint 1 and click the Teach Pendant icon. Click OK to save this waypoint. Now you have configured the first waypoint in the robot program. Next, click Move J in the program tree. And click the Structure tab. Then click Move to insert. Here, a move L is needed. To change it, click the Command tab and select Move L in the drop-down menu. The motion is now changed to Move L and set. Drag the TCP to waypoint 2 and click the Teach Pendant icon to save this waypoint. Now you have configured the second waypoint. To insert the third waypoint, click Move L in the program tree and click the Structure tab. Then click Move to insert another motion and waypoint. To change the Move J to a Move P, click the Command tab. Select Move P in the drop-down menu. The motion is now changed to a Move P. Click the waypoint and set this. Drag the TCP to waypoint 3 and click the Teach Pendant icon to save this waypoint. Now you have configured waypoint 3. Click Add Waypoint After to add another waypoint up. Next, click Set this waypoint. Drag the TCP to waypoint 4 and click OK to save this waypoint. The next motion needed is a circle move. Click Move P in the program tree and add circle move. A circle move consisting of 2 waypoints is inserted. To move it to the correct place in the program tree, click the Structure tab and then click the Move button with the down arrow. The circle move is now in the correct place. Click the first waypoint to configure it and set this. Now drag the TCP to waypoint 5, which is the via point of the circle move. Afterwards, click the Teach Pendant icon. Click OK to save this waypoint. Now you have configured the via point of the and set this. Drag the TCP to waypoint 6, which is the endpoint of the circular move, and then click the Teach Pendant icon to set this waypoint. Now you have configured the entire circle move. Click Move P in the program tree to insert the next waypoint. And then click the Structure tab. Click Move to change the motion to a Move P. Click the Command tab. Then select Move P in the drop-down menu. Click the waypoint to configure it. And drag the TCP to waypoint 7, and then click the Teach Pendant icon. Click OK to save this waypoint. Now you have configured waypoint 7. To add another waypoint of the same type, click Add Waypoint After. And then drag the TCP to position 8 and click the Teach Pendant icon. Click OK to save this waypoint. To insert the final waypoint, click the last Move P in the program tree and click the Structure tab. Then click the Move button to insert the final motion and waypoint. Here, you need a Move L. Click the Command tab, select Move L in the drop-down menu. Next, click the waypoint and set. Drag the TCP to its final waypoint and click the Teach pendant icon. Click OK to save this waypoint. You have now set up all the motions and waypoints needed for this program. Let's see it in action. You have now completed the module. Here's a short recap. Move L is a linear motion that is typically used to pick up or replace a workpiece. Move P is a process motion that is typically used when the TCP has to maintain a fixed speed. Move J is a non-linear motion and also the fastest motion type. It is typically used when moving in free space. Move C is used to make circular motions.